Hello everyone. So today I'm going to be writing a program to convert a decimal number to a binary number using C language. And we are going to be using recursion. Recursion is a way of solving a problem by dividing that problem into a smaller problem until a base case. So now let's start. So we are going to include stdio header file and our main function. We'll start by writing our function prototype, and it's not going to return anything, so we'll be printing the result. So void, let's call the function this, and it's going to take in integer argument. Now we need a variable integer. N is our integer variable, and we are going to ask the user to enter a number. Alright, and scan it. We are taking the input from the user and then we are going to store it in N. So ampersand N means that this is the address of N, and that value that we get from the user is going to be stored in N, in this variable N. And you put ampersand in front of a variable to indicate that it's the address of that variable. So address of N. Now let's call our function and N. We are going to pass N as the argument. Alright, now let's start. So this is our function name. Yes. Now let's start. Now for any recursion to work, we need a base case. So what exactly happens when we convert decimal to binary? We are basically dividing that number by 2 and getting the remainder. And we keep on finding out the remainder by dividing by 2 until the number is 1 or 0. So the base case should be if n equals to 1, then I want it to print 1, and then I want it to return back to the function call that I had made. So I'll be calling this function again, and I keep on I just want it to divide by 2 until it reaches the base case. So let it keep on calling this function again and again. Then when it will become 1 and will be 1, then it will print this 1. It will come back here, and then I want it to go back down the stack and printf %d, we need a yes, and n percentage, which is n mod 2. So basically what it will do is, suppose the number is 10, then 10 is not 1, so it will come here, it will call this function again with 5. 5 is not 1, again it will call. This will go on and on until the number becomes 1. When it's 1, then it will print 1. Now recursion uses stack. So this is the topmost element of the stack, one portion of the stack. Now it will keep on going back down the stack. So it will remember, it will store it all. So then it will come back to the function call and print whatever was there here. And this will go on. So let's see if it works. 1010 should be the output. Let's see. Yes, it's working. So binary equivalent of 10 is 1010. So like I said, it remembers the state. It works like a stack, and that's how once the base case is printed, it will go back again down the stack and print all the cases. Let's see what happens if the base case is 0. Like, what if I change n equals to 0, then you print 0? What will happen? Let's see. What I think would happen is maybe there would be a leading 0 here as well. Like, if you want binary equivalent of 10, maybe it would print 0 1 0 1 0. Like, there will be an extra 0 in the start. Let's see what happens. I'm saving. Now let's compile it. Yeah, so an extra 0 comes. So that's not exactly a problem, but I like the number to appear like this, 1010. We should also include one more case for n equals to 0, so that if the user enters a number, say 0, then the binary equivalent should be 0. So that case should also be included. Otherwise, if we had not included this case, then for 0 it wouldn't work. Right, everything else is going to be the same. Now let's compile this. Right, now suppose if I enter 0, yeah, now I'm getting 0. For now, let me comment this. Okay, we're going to write one more function with a different logic, and it's recursion only. If you want to comment an entire block of code, then you simply select that code and then press Ctrl plus slash. Now let's start. Our base case, in this case I'm going to take if n equals to 0, then I want it to return 0. In this case, it's not a void function, it's a int. It's going to return a value, so we have to change it here as well, and here also there will be some changes. So what we can do is we can add another format specifier, and since it's gonna have a return type, so it's gonna be returning, and let's see if it works like this. Okay, anyways, let's go back to our function. So we have the base case here. Now what I'm basically doing is I'm going to be returning the remainder of that number, because that's what we do while finding the binary equivalent of a number, right? So we return the remainder of a number, but then I'm also going to add 10 into that n divided by 2 and multiply 10 with the again another function call, and don't forget the semicolon. Right, so I'm multiplying 10 because it will reverse the numbers. Like whenever you find a binary equivalent, normally like when you divide it by 2 again and again and find out the remainders, so in the end you write it in the reverse order, right? Whenever you find out, whenever you get a 0 or 1 in the end, when the number becomes 0 or 1, then after that you write the binary equivalent in the reverse order. It's like a stack, right? The last remainder that you get, from there you start writing all the remainders till the first one that you got. So it's reverse order. That's why you need to multiply 10. We're multiplying 10 because we want to reverse the order of the remainders, because that's what happens when you find the binary equivalent of a number. When you find out the remainder by dividing it by 2 again and again until the number becomes 0 or 1, then in the end you write it in the reverse order, all the remainders, and that is your binary equivalent. Similarly, here also we have to account for that fact, and that is done by multiplying 10. that changes the place of the number. Suppose it's 10, so 1010. 1 is in the thousands place, right? In the number. So it should be in the thousands place. So it's at opposite order. That's why you need to multiply 10. Instead of directly printing and using the return value in the printf, you can use another variable called result and store the return value of the function and then print result here. This will also work perfectly fine. It's working for 0. Suppose I enter 10. Perfect. Suppose I enter 2. Yeah. When I was running this program, then it wasn't working for the number 0. Like whenever the user was entering 0, then I wasn't getting the output. Like all the other numbers were working, but only 0 wasn't. And the logic is correct. So I decided to delete the exe file and again compile it, and then it worked. I think it wasn't working because it wasn't compiled properly. So if you guys face this problem, then I would suggest that you maybe delete the exe file and compile it again. Another safe option is to create another variable result and then store the value returned in that variable and then type result here instead of directly writing the function. There are many different logics that you can try out and everything works as long as you've understood the concept, you've understood the base case, how you would think of the logic, and understood how stacking actually works in recursion. Then I'm pretty sure that you will understand this. If you find out any other logic to solve this, then try that out as well, because there are many logics, many ways to solve a problem. And when you try out different logics, then your mind opens up more and you become better at thinking. So that's it for today. I hope you guys understood and had fun in this video, and see you in the next one. Bye.